This is number 56 from page 419 in the textbook. It states that a parking lot has the shape of a parallelogram. The lengths of two adjacent sides are 70 meters and 100 meters. The angle between the two sides is 70 degrees. What is the area of the parking lot? So it basically wants us to find the area of a parallelogram using the law of sine and cosine. So the initial problem doesn't give us much information. It gives us two side lengths and an angle measure. But with our knowledge of parallelograms, we can fill in a little bit more information. So obviously, first things first, it's a parallelogram. So the sides are parallel to each other. So this side is parallel to this side, so we can fill in that that is also 70 meters. Same thing with this side. This is also 100 meters. Now for the angles, these are opposite angles, meaning they're equal, basically. So this is also going to be 70 degrees. And these two angles, or these two angles, however you want to look at it, are supplementary angles, meaning that they add up to 180 degrees. So 180 minus 70 equals 110. And because these are opposite, again, it's going to be 110. So now that we have all the information about our parallelogram, we want to apply this information to our law of sine / law of cosines notes. And with those notes, we have to have triangles, and we don't. So to do that, to get our triangles, all we're going to do is cut our parallelogram, and if we cut our parallelogram in half, we now have two congruent triangles that we can now use the law and sines with. So I'm just going to plug in our information that we have from here onto this. But it's going to be a little bit different because since it was split up right where the angles were, right here and right here, these angles are now cut in half. So this is now 35. It doesn't look like a 35, but it is. And that's also a 35. And this is still the 110. And the side lengths are the same. So this is 100 meters. This is 70 meters. So now with this, the next thing that we're going to do is label, because in law of sines and law of cosines, we have our sides labeled. So I'm going to do this one A, this as A, this B, this B, and this C, this little C. So now, finally, we can use our law of sines or law of cosines. Now we gotta find out which one we're gonna use. So, taking our notes, law of sine notes, seeing if any of these work, and check the first one. So, angle side angle. If we have angle side angle, we can use law of sines. So we have an angle, we have a side, we have an angle. So we can use angle. We can use law of sine. And law of sine states that the sine of A over A equals sine of B over little b in little a equals sine of C over little c. So we're looking for this little c because we don't have it. That's the only number we didn't have. So since we're looking for this little c, this side is not really relevant. All we need is this. So sine of b over b equals sine of c over c. So we can write that right here. Sine of b over b equals sine of c over C. And we can now plug in the numbers. So sine of B, or 35, that doesn't look like a 35, over RB, which is 70, equals sine of C, which is 110, over little c, which we don't have. Okay, so now we can cross multiply to find what c equals. So c times sine of 35 equals 70 times sine of 110. So right there. And we're gonna get c by itself. So we're gonna divide by sine of 35. Leaving c by itself, so c is equal to sine of 110 times 70, or 70 times 110, I can just flip it around, times sine of, divided by sine of 35. And so we just plug that into our calculator. Plug that into our calculator. So sine of 110 times 70 divided by 30. Sine of 35. So we get 114.68. So this is equal to 114.68. Right there. Fix that. So we still do not have enough information to find out what our grand area is. Now that we have all the information that we need for the triangle, we want to now find the area of the triangle so we can then find the area for the parallelogram. But we don't have the basic base and height to do the 1/2 base times height for a triangle, so we'll have to find another way to do area. And we can use the area of an oblique triangle, that's also in our notes. Which states that area, put A, is equal to 1/2 AC sine B. And we'll just plug that in and we'll get to find the area. So 1/2 of A, which is 100, C, which is 114.68. Oops. Ooh, messed that up. 114.68. Oops. Times sine of B, which is 35. So again, plug that into our calculator. Times 114.68 times sine of 35 divided by 2, or times 1/2, either way. You get 3288.89. So the area is equal to 3288.89. What's up with my writing? So that's the area of just this triangle. But we want the area for the parallelograms. I like I mentioned before, these two triangles are congruent, meaning they're equal to each other. So I take the 3288.89 and multiply it by 2 because of the two triangles, which are the exact same area, and you get 6577.78, which is the area of the total parallelogram. So 6577.78 meters squared is the area for the parallelogram. So that's your solution.